Hello everyone. In today's class, we are going to learn some of the most important concepts in object-oriented programming: declaring objects, object reference, constructors, access modifiers, and this keyword. Let's start with declaring an object. Remember that in Java, everything revolves around objects. So before using an object, we first declare a reference variable. So the syntax is class name and object reference. For example, student S. So here student is the class and S is the reference variable. This statement does not create an object. Many beginners think this creates an object, but it does not. It only creates a variable capable of storing the address of a student object. At this moment, S is equal to null because there is no object in memory. Now let's actually create an object. So this is done using the new keyword. Student S is equal to new student. So the new keyword performs three important tasks. First is allocates memory inside the heap for the object, and then it calls the constructor, and then it returns the object's address. That address is stored in the reference variable S. So remember, reference variables live inside the stack and objects live inside the heap memory. The heap stores all objects. The stack stores only local variables and references. So once an object is created, we access its members. And object members include variables and methods. So Java uses dot operator. Object dot variable, object dot method. So here s dot name is equal to Joe. That is, name is Joe, and then the function is display. So the name is an instance variable here. Display is a method. The dot operator tells Java, go to this object and access this member. So without the object, instance members cannot be accessed. So we can also create multiple objects of the same class. So here S1 and S2 are two objects of the same class student. So object references. This is one topic where students commonly make mistakes. So let's understand object references carefully. So student S is equal to new student. So this is the main one object. Now we are creating another two objects. Student S1 is equal to new student. So this creates one object. Now student S2 is equal to S1. So does this create another object? No, it only copies the address. So memory becomes like this. Both variables point to the same object. Now, when we display s2.name is equal to Rahul, and then we are displaying s1.name, it shows Rahul. Students often expect the output to be empty, but since both reference points to the same object, changing one reference changes the same object. So what is stored inside an object reference? The memory address of the object. So when we create an object using new, the actual object is stored in the heap. But the reference variable, it is the name we use, is stored in the stack memory. So this is how the object references work. An object reference does not store the actual object, only its address in the heap. And assigning one reference to another does not copy the object, it only copies the reference. And multiple references can point to the same object. Null references exist, but no object is assigned. And Java has automatic garbage collection for unreferenced objects. Now we will see what constructors are. So a constructor is a special member in Java used for initializing objects. So it is automatically called when an object is created. So it has the same name as the class and it is used to initialize the object. That is, it can set initial values for the variables. And it has the same name as the class and it has no return type, not even void. And it automatically called during object creation and it is executed only once. If no constructor is defined, then Java provides a default constructor. And if you define any constructor, then the default one is not provided. And constructors cannot be inherited, but can call parent class constructors using super keyword. And constructors can be overloaded also. So this is a constructor, student. So when we create student s is equal to new student, immediately Java executes the constructor, even though we never called it ourselves. That's why constructors are called automatically. Now let's see the different types of constructors in Java. So the first type is default constructor. So default constructor is a constructor automatically provided by the Java compiler if you do not write any constructor in the class. If you define any constructor, then Java does not generate the default constructor. So here we have an example, class student, and it has two variables, name and age. Now in the function display, we are displaying the name and age. In the main function, we are creating an object S. So here there is no constructor defined here. So Java provides a default constructor. So when we create a new object S, then it calls the compiler generated default constructor. And when we here we are displaying uh, the object. So the output will be displayed as name null and age equal to 0 because we have not assigned any. Next is no arguments constructor. So this constructor is written by the programmer and it takes no parameters. So this is the normal constructor. It's like the student. This is a no arguments constructor. There will not be any arguments inside the parenthesis, and we can print the. We are printing constructor here. And this is another example. Class car. Here car is the constructor. The name should be same as the class name. And here we are printing car is created, and in the main function we are calling the constructor. Car C is equal to new car. Then object is created and it also calls the constructor. Next type is parameterized constructor. This constructor accepts values during object creation. So here we have an example, class car, and model is an instance variable, and this is the constructor. Car, here there is a parameter like string m. Here we are assigning model is equal to m, and here we are printing the model. So in the main function, when we create the object, we can assign, we can create a value also. We can assign value. Here it is Honda. Then when the object is created, the Honda value is passed to the constructor. So the object is initialized immediately. The next type is copy constructor. So this is a constructor that creates a new object by copying data from another object. So here we have a class called car and we have two constructors. So first in the first constructor we have a string m, and in the second constructor we have car c. So here in the main function, we are creating an object car C1 is equal to new car Hyundai and car C2 is equal to new car C1. So here we are not assigning the value, but we are copying data from another object. So here also Hyundai will be there. And we are then printing C2 dot model. Now when we where the output will be Hyundai. Now let's see about this keyword. So this is a reference variable in Java and it refers to the current object. Suppose a student string name, this dot name is equal to name. So here both variables have the same name. So without this name is equal to name, then Java cannot distinguish between the parameter and the instance variable. So this dot name refers to the instance variable and name refers to the parameter. So this is implicitly available inside instance methods and constructors. Why do we need this? So this is a useful keyword and it is used to differentiate between instance variables and parameters when they have the same name. And we can also use this to call other methods or constructors from within the same class. And we can also use this to pass the current object as an argument and also use to return the current object from a method. So we will see this in detail. So here we can use this to resolve variable name conflicts. Here we have an example, class student. Here we have two variables, name and age. So this is the constructor student string name int age. So these parameter names are same as instance variables. So this dot name is equal to name. So here this refers to instance variable and this dot age is equal to age. Now we are displaying it in the main function. We are creating an object and we are calling the method to display it. So when local variables like parameters shadow instance variables, we use this to access the instance variable to resolve variable name conflicts. Without this, the assignment would only affect the parameters, not the actual instance variables. Next one, this is also can be used to call another method of the same class. Although Java automatically does this, writing this dot display makes it explicit. So here we have a class demo and void show system.out.println hello from show. And the function called this dot show. So this is same as just show. Next is using this for constructor chaining. So one constructor calls another constructor in the same class. Remember, this must be always be the first statement. So here uh, in the class student, we have two instance variables, name and age. In the constructor, we are uh, calling another constructor, this unknown 0. And in the student string name int age, this is another constructor. This dot name is equal to name and this dot age is equal to age. We can also use this to pass current object as an argument. So here we are passing the current object itself to another method. So this is useful in event handling and callback methods. So here in the class test, void display test D, here we are printing a method called using object. And here void call display this. So here we are passing the current object as an argument. So we can use this to resolve variable conflicts, call another method, constructor chaining, and we can also pass the current object using this. And this can always refers to the current object and it can be automatically passed to all instance methods. It cannot be used inside static methods and these are the common uses. Now we will see the access modifiers in Java. So in Java, access modifiers are keywords that control the visibility or scope of classes, methods, variables, and constructors. So access modifiers decide who can access a class or its members. So let's understand each one. First is private, then we have default or no modifier, then public and protected. So these are the four access modifiers. So first is private. Private means we can access only inside the same class. It cannot be accessed from outside the class, and private is mostly used in encapsulation for data hiding. So here we have a class test. Here we are creating an instance variable data is equal to 10 as private. So it can be accessible only within the same class. Now we are printing a private method inside the method show. This function is also private. And in the main function, we are creating an object T, and then we are printing with member data, the variable data, and we are also calling the function. So here this is allowed because it is in the same class. Now in the main class, another class demo, this is the main class. Here we are creating an object P, and here we are, if we try to access this data or show function, then it will show an error because this is not allowed here because it is private. Next type is default. So if no modifier is specified, then Java will take it as a default one, and we don't have any keyword to represent the default specifier. So this is accessible within the same package only. So here we have an example, class test integer data is equal to 20. So here we haven't mentioned any specific modifier, so it will take as default. Then in the display function, we are printing default access. And in the main class, we are creating an object T. Now we are trying to print the variable data, and the function is also called. So this will show the output because this is accessible within the package. So there is no problem. Now the third one is protected. So this is accessible in the same package and also by subclasses outside the package through inheritance. So here we have an example. We have two packages. This is the first package. Here we have class parent. Parent is declared as public, and we have a protected function called show. Here we are printing protected method. And this is the second package, pack 2. Here we are importing a pack 1. This is the parent class. So here we are using inheritance, class child extends parent. So here we are creating an object C, and here when we try to access the show method from the parent class, it is allowed. The last type is public. Public is accessible from anywhere. There is no restriction on visibility. So here we have a class test, and here we have a function display to print public method. And in the main function, sorry, main class, we have created a object T, and here T dot display. So this is accessible everywhere because this is created as public. So this is the display table. So private is only inside the same class. Default is accessible only within the same package, and protected accessible in the same package and also by subclasses outside the package through inheritance but not in other packages. Public means they can accessible from anywhere.